So now let's talk about logistic regression with gradient descent. The concept is quite similar to what we have learned in the case of multivariate regression. Only the cost function has been changed, but the concept of gradient descent remains the same. So here you can see the cost function is this new cost function in the case of logistic regression. So whenever you plot now this new cost function, it will come something like this, and this is a convex curve now. And in this convex curve, our main goal is to find, that is, this global minimum. Now this global minimum will be found by the gradient descent approach. So gradient descent is basically taking a small step one by one. So you are going to take a small step by the help of a step size and a gradient, and you are just taking this step size until and unless you reach to this global minimum, and that is all about the gradient descent. Now let's see the gradient descent with respect to logistic regression. So only the change here is basically this formula is now the new formula for the cost function, and good news is this is now convex function. Now it is convex, not the non-linear function. So we will find something like this curve, which we have been basically seeing in the case of linear regression. Same curve will be used, and the formula is also the same. Only the change over here in the case of that is linear regression and that is logistic regression is this j theta. J theta is nothing but the cost function. In the case of that is linear regression, we use this j theta as, in the case of linear regression, we use this j theta as MSE, which is mean squared error. In the case of that is linear regression, in the case of logistic regression, we will use this j theta, that is cross entropy. So cross entropy is nothing but this equation, which is this log equation. So basically this formula is of the gradient descent. We are going to optimize with the help of learning rate, and learning rate is basically going to be the way to just take this step size. Basically it is going to just impact on us this step size. So if you take the value of alpha, this learning rate too high, then you might overshoot your gradient descent or global minimum. And similarly, if you take this value of alpha that is too low, then your learning process will be slower. So just take this alpha, that is adaptive alpha, based on your problem, and this j theta is nothing but this cross entropy. You have to take the derivative of it and update this theta similarly. So the partial derivative will be same, and in this way you are going to update the theta one by one for this gradient descent approach. So gradient descent is quite similar to what we have learned in the case of that is linear regression. So we learned this was the case of that is linear regression. If you remember, this was the case of linear regression. Now in this case, what we are going to do is we are going to just take a derivative. Now this is j theta with respect to that particular parameter that you are going to tune. So if I am going to tune theta naught, then I'll just say theta naught, the old theta naught, minus the alpha times, and just take the partial derivative of our cost function, which in this case is this cross entropy function, with respect to theta naught. So for the theta naught, you are doing with respect to theta naught. For if you want to update theta 1, you have to do now with respect to theta 1. So that is will be j theta with respect to derivative of theta 1 for the theta 1, and similarly for the j, it will be in respect to j. So this was in the case of linear regression. So simultaneously you will update all the theta j, and theta is basically dependent on your that x's, that is input. So how much input you have, so that much will be your that is theta. So theta naught should be also updated. Let's say if you have like two inputs means you have x1 and x2, then in that case you have to optimize three parameter. First one will be theta naught. To optimize, theta naught is nothing but a constant. You have to also update this bias. So this is a bias, you have to update this also using this gradient descent approach. Similarly, you have to update theta 1, which will be associated with x1, and theta 2, which will be associated with x2. So for each of this you will apply the gradient descent. Only the change will be this j theta. And we are going to use the library in order to implement this gradient descent. It is very easy to do with the help of library. Just remember the concept about the gradient descent, how this gradient descent is going to go in the iteration to basically fetch or to basically go at this end position where we have this global minimum, and it is a iterative process. So that means you will use the iteration with the help of this alpha learning rate and a step size. So that is all about this logistic regression. I highly recommend, if you have any confusion regarding to the gradient descent, then just check out our video where we have covered the multivariate regression. So logistic regression is quite similar. The gradient descent purpose or gradient descent work is quite similar. Only the change is here the cost function j theta. So only the change is a j theta. All the concept will be similar to what we have in the case of, that is, multivariate linear regression. So that is all in the case of logistic regression. In the next workshop video, we are going to implement the code of the logistic regression and do the classification tasks. See you in the next one.